Robert, we have everybody back on your end?
Well, we've got probably about half the class back. Robert had to step out for a few minutes.
Okay.
But you were pretty clear about when we should start. If you want to jump back in, go for it. We're listening.
All right, cool. Sounds good. All right, so we're gonna jump into some code. Slowly jump into some code with EJB development. First thing that we need to establish are the pieces that we need to create in order for us to have a valid enterprise JavaBean. So we'll just quickly go through the list. Again, in EJB3, it's a lot easier than it was in EJB2. EJB2, I actually had to create 5 different artifacts. I had to create a home interface, a business interface. I had to create an implementation. I had to create 2 XML files. In the EJB3 world, I really only need to create 2, potentially 3 artifacts, depending on which version of EJB3 I use. So generally we say to have good object-oriented design in EJB3, you'll want to have a business interface. The primary reason for that is that the business interface becomes the type that shows up in the JNDI tree. And then you'll want to have, obviously, your implementation of that interface. The potential third element in EJB3 would be the XML file if I wanted to do some special or additional configuration. The XML file, it contains what we would call the metadata. The tendency generally is to try to use as many annotations and as many attributes of the annotations as possible to embed that metadata in our Java code. And then if we need to override the metadata, changing the value of a bean name or changing the path where the bean will be deployed, we would do that in the XML file. So default configuration, generalized configuration is in the metadata baked into the Java code through annotations. Special configuration or special circumstances, I'll override that in the XML file. If I don't provide any metadata information beyond just the annotation, what's going to happen is that the container is going to use some default values for the EJB name, the JNDI name, the type, security, and transaction information. Generally, what's going to happen is that the EJB name is going to be the class name. The EJB JNDI name is going to be the fully qualified class name. The EJB type is going to be the interface that the class implements, so the business interface, in other words. And default, there's going to be no real security, but there's going to be container managed transactions. So if I don't supply metadata, the container is going to do some intelligent defaults for me. From a development perspective, I'm basically going to go through a few different steps. It's arguable what's first, the chicken or the egg. If I have the egg first, I'm going to write the client. If I have the chicken first, I'm going to write the EJB first. At the end of the day, I need to write my EJB. So generally, I'm just going to follow good Java structure. I'm going to write my interface, build my implementation. I'm going to configure my EJB primarily using annotations. I'm going to compile. Everybody knows how to compile with Java-C. I'm going to package, throw everything in an EJB-jar file, and then I'm going to go ahead, generate the client access classes. What that means to me is that if I have a remote EJB, I need to take the business interface, place it in what's commonly known as a client jar, and make that client jar available to the client. Then I deploy, I'm going to shove the EJB jar out to the application server, and I do my testing, so on and so forth. So that's kind of the multi-step process that I'm going to go through. Obviously, I would want to use something like Ant or Maven to automate as much of that build and test as possible to save myself a few mind-numbing steps. When I go to deploy my enterprise JavaBean, again, remember this is going to be in an EJB jar. You'll see that in my EJB jar, I'm going to have a manifest directory. That is required from the jar utility. Every jar is only valid if it has a meta-inf directory, and in that meta-inf directory, a manifest.mf file. Inside of that meta-inf directory, I may or may not have an EJB-jar.xml file. Remember, if I'm using EJB 3.1, it's not required at all. If I'm using EJB 3, it is required, but it's not going to have any contents. Excuse me. And then the last thing that you'll notice I have in my jar file are my interface for the bean and my implementation class. So pretty straightforward. Pretty simplistic jar structure. Questions on either the steps or the structure of my jar?
Nope.
Okay, great. Let's look at...
What version of Java do you need for 3.0, 3.1? Is there a certain...
What version of Java do you need?
Yeah.
Yeah, so because EJB3 relies on annotations, you need at least Java 1.5.
Okay.
But you don't need Java 6.
All right. Thank you.
You're welcome. Other questions?
Nope, I think we're good now.
Okay, great. So let's look at these session bean concepts. Quick review, we've got 3 different types: stateless, stateful, and singleton. Stateless and stateful exist as extensions of the client. Stateless has no client data. Stateful does have client data. And remember that there is a different annotation to use for each one of those. A couple of different little decision points. We're not going to spend a lot of time on this. I've already kind of mentioned it earlier in the presentation. The big decision point between stateless and stateful is how much client data my session bean needs to contain. If it needs to contain no data, client data, use stateless. If it does need to contain client data, use stateful. If you want to know more details on which bean to choose, here's a little chart that shows you kind of a more detailed analysis of what's available, what's not available. So what is worthwhile for us to look at are the bottom 2 rows in that chart. What I want you to recognize here is that stateful beans are unique per client. So what that generally means is that I have a one-to-one relationship between stateful instance and client accessor. So if I have 100 simultaneous clients accessing my stateful session bean, I will have 100 instances of that stateful session bean in memory. And if I have 1,000, I have 1,000, so on and so forth. So it's a very linear scale. If I don't want that behavior, and I want to be able to reuse objects, have a single object accessed by multiple clients, I'm either going to use a stateless bean or a singleton bean. The difference between the two and how this many-to-one relationship works is that in the singleton, it's truly a many-to-one. I have physically one instance and hundreds of thousands of clients accessing that instance at the same time. In the stateless world, the many-to-one is created through a pooling structure. Most application servers allow me to configure how big my stateless pool is, how many objects can exist in that stateless pool. And then when I have a client that makes a request, or I have multiple clients that make simultaneous requests, it'll look like and feel like I have a many-to-one relationship, but in actuality, the container is going to grab a free object from the pool, associate that free object with the client's going to use it for the transaction, however long the transaction is, and then the object is going to be placed back into the pool. Okay, so stateless gives me that kind of pooled structure. The key thing to recognize is that in both stateless and stateful session beans, I will only ever have one thread interacting with that bean at any given time. In other words, both stateless and stateful beans do not support concurrent access. So the good thing from a software design perspective is I don't have to worry about synchronized blocks. I don't have to worry about, data corruption. I don't have to worry about deadlock, things like that, because I truly only will have one thread interacting with them at any given time. Questions on those concepts? All right, so let's look at how we're going to actually build one of these fancy things called a session bean. We've gone through the steps already. We're going to just trim down the process to 5 steps. Create the business interface, annotate the business interface with my client access mode, create the session bean, implementing the business interface, annotate the session bean with my appropriate session bean type, compile, deploy, debug, so on and so forth. So as a review, we know that there are basically 4 different types of client access modes available for a session bean. I've got local, remote, LocalBean, and web service. We're only going to look at 2 because if you understand how to create one, you'll understand how to create all 4. The business interface for a session bean is just a plain old Java interface. I think that's a POJ instead of a POJO, or a POJI instead of a POJO. Anyway, in my Java interface, it's going to be a public interface. It's going to have its name. In there, I'm going to have my public abstract methods. In this case, we just, have something like this, get some property as the method name. My interface can still have the public static final constants if I wanted to. Most people have moved away from that from a Java development perspective anyway in favor of the new enum type. But point there is that I can still use it if I wanted to. So let's look at a simple interface now that we know the rules. Again, we mentioned early on that we're still going to use the JavaX EJB package, standard old import statement right there. Should be nothing foreign to you with that statement. Next thing that we have on line 9 here is the application of the annotation. And remember that the annotation structure or the annotation syntax, I use the @ sign to declare that I'm applying a special type. And then every annotation has a name because an annotation is a class. So I take the type and the @ sign together combines the annotation. Is the annotation structure familiar or unfamiliar for you guys?
Familiar.
Familiar? Okay, great. So this annotation is what I would call an empty annotation. If the annotation had additional meta information provided, I would see some parentheses, and then in the parentheses I would see some name value pairs. Again, that's going to provide additional default configurations. I would generally use that to overwrite the EJB name or overwrite the JNDI path, so on and so forth. So the next piece, I got my standard old Java interface, nothing really crazy there. I got 4 different methods. Should be familiar to everybody. If I were to create a remote representation, similar deal. Go ahead and import the annotation, apply the annotation to my interface, and I'm done. It should be pretty straightforward for you to imagine in your mind right now that if I were to create a web service interface, I would change the word remote, replace it with the word web service. So idea there is that it's pretty easy to change the access mode. When I go to build my actual enterprise JavaBean, there are a few rules that I need to follow. First and foremost is that the enterprise JavaBean should look like a true JavaBean. If you're not familiar with true JavaBean, JavaBeans was a component specification defined probably 1997, 1998, something like that. The intent of the JavaBean specification was to create reusable components within graphic application development. Today, when most people talk about a POJO, plain old Java object, the structure, the coding convention, so to speak, for a POJO is derived from JavaBeans. The get and set mechanism is derived from the JavaBean specification. The no argument constructor in a POJO derived from the JavaBean specification. Okay, so generally, I'm either going to follow the JavaBean specification or what we would call a POJO. From an implementation perspective, obviously the implementing class needs to implement the interface. If it doesn't implement the interface, we've got to make it abstract, so on and so forth. So once we've implemented the POJO, the next thing that we'll do is we'll annotate it with one of these 3 different annotations. And again, it should be pretty straightforward. So let's look at an implementation. First implementation here, again, I import my annotation. I define my local calculator bean that implements my business interface. Obviously, I provide my implementations, so on and so forth. The thing that makes this bean a stateless session bean is the application of that stateless annotation. Without it, it truly just would be a plain old Java object. There is much debate in the EJB development world on whether or not you should include the word bean in the class name or whether you should include the word EJB in the class name. I'll let you guys duke that out in the schoolyard to figure out what coding convention you want to follow or don't want to follow. Very simple example of a stateless session bean. Alternate example is now I have a stateful session bean. Again, I've got the implementation of the interface. I've got the methods that correlate with that interface, and then I make this a bean by applying that annotation. So in this scenario, I have a calculator that is a stateful calculator, and the stateful calculator can be accessed by a remote client. In EJB 3.1, I can, as I mentioned earlier, I can create an enterprise JavaBean without an interface. It's also known as a no interface bean. And what generally happens when I do this is I create a class. When I develop the class, I have the class exist without a business interface. I tell the container that the bean is a local bean, and the container will dynamically introspect the class or the bean. And for every method that's defined as a public method, it will be exposed in what will be dynamically generated as the interface. So in EJB 3.1, point is, I don't have to have the interface. One can be created on my behalf. Okay. In this case, you'll see this example using both of the new features in EJB 3.1, LocalBean and Singleton. Questions on basic implementation structure? Okay, great. So let's talk about how to access these session beans then. So we looked at the implementations. Obviously, the step that would happen from our summary slide to the accessing session bean slide is that I'm going to compile, I'm going to build my jar, and I'm going to deploy my jar in the app server. Okay, so let's assume that's all done. and I've got a healthy enterprise JavaBean application running in my app server. And now I want to access it. There are a couple of different ways for me to access this enterprise JavaBean. Remember that from an access perspective, I don't have direct access to the EJB. Instead, I have to go through a proxy. The proxy, remember, is created by the container on my behalf. It protects the physical instance. So when I talk about accessing an enterprise JavaBean, I'm really talking about accessing the proxy, which then forwards the calls to the EJB. Clients for an EJB generally are going to be other Java applications or other Java EE applications, other Java EE components like JSP service, JSFs, things like that. Generally, I'm not going to have a .NET application directly call my EJB application, or I'm not going to have a COBOL application directly call my EJB application. While I could, using Corba, most people, if they have the mixed environment enterprise, will rely on web services to make those client interactions. In order for me as a developer to find and work with those EJBs, remember again, I'm going to rely on JNDI. And in the context of JNDI, I really have two different options. I can either do it the manual way, where I create a context, I do the lookup, I cast the results of the lookup into an EJB, or I can rely on dependency injection. And again, dependency injection is going to be the easiest way for me to find and work with my EJB. When I go to build a client, a couple of things to quick note. One, again, I am never going to call the EJB's constructor directly. It's hidden from me. That's the first thing. Second thing is that when I declare the reference to my EJB within my client code, remember that I want to declare that reference against the interface and not the implementation type. A couple of reasons for that. One, which is the most obvious, is that if the implementation changes, I've got to go back and change my client code. Pretty bad idea if I'm dealing with an N-tier or a distributed system. Second thing is that there's no guarantee that the implementation class is the class name of the entity in JNDI. Most containers will use the interface for the class name or class type in JNDI. So if I did declare a reference based on the class name, I could theoretically get some form of a class cast exception. Again, remember, I'm getting back a proxy. We don't really know if that proxy is an instance of the class or not. We do know that it is an instance of the interface, but not the physical implementation. So those are the two things to remember. Can't call a constructor, deal with the interface and not the implementation. So I'm going to assume everybody has familiarity with JNDI. A quick review, JNDI maps some data store. Data store is usually organized around a tree. Tree is composed of nodes. Nodes have name-value pairs. In the Java world, the name is a key, the value is an object. In order for me to work with JNDI, I need some context. That's basically just my view, so to speak, into the data store, whether it's LDAP or Active Directory or so on and so forth. I need a starting point within that context. Am I at the root node, or am I, 4 levels down the directory structure? And then I need some key value pair structure. If I have all of those things, then I can go ahead and do a search, or I can go ahead and do a lookup and hopefully find the resource that I'm working with. Usually when I use JNDI, we talk about context in two different forms. We have a local context, which means the JNDI object that I'm working with is initialized to the actual deployment artifact that I'm working with. So it's initialized to my EJB Jar context, or my WAR context, or my EAR context. And then I have a remote context. Remote context means that I'm creating a JNDI object that references or points to some remote server. when I am using dependency injection, generally dependency injection is going to rely on a local context to facilitate its lookup. If I have an EJB and a WAR deployed together in an ear, the dependency injection will function as if it's working within a local context, even though it may truly be a remote context. But generally, whenever we use dependency injection, if it fails, it's because we are trying to inject a resource that belongs to a different context than the one we're trying to access. Let's skip over that. So let's look at how to create an initial context. Two different ways that I'm going to create an initial context. The first way is that I'm going to use some default configuration that's either provided by the container manually, or it's provided by a jar that contains JNDI properties. The second way that I could create an initial context is I could physically build an initial context based on some environment values. At the end of the day, once I have an initial context, or once I have a reference to that context, I can go ahead and look up my resources. In EJB3 and in EJB2, each application server vendor came up with a different naming structure for their enterprise JavaBeans. You'll notice on this slide it says in EJB 3.1 there is a new global JNDI naming convention, which basically means that regardless of the application server that I'm working with, the JNDI pathing name structure will always be the same. So it makes development a lot easier. I don't have to worry about am I deploying to a WebLogic or am I deploying to JBoss. It means I don't have to worry about changing the hard-coded values in my Java code. There's consistency. Once I know the JNDI path, then I can go ahead and do my lookup for my resource. So here's a real simple example. In this simple example, we are using the fully qualified class name for the interface as the JNDI path. You'll note if you think back to the slide where there are the new naming conventions, one of the options is the fully qualified class name. The other options are path-based. So this is just the simplest example to illustrate. Anyway, I go ahead and I define my JNDI path. I go ahead and define my initial context. You'll notice that this application is a standalone Java application. That means by default Java SE does not provide default values for the initial context. So that means in this particular example, I probably have a JNDI.properties file in the class path, or I'm relying on a jar that contains a JNDI.properties file. I go ahead anyway, once I've got that initialized context, I go ahead and perform my lookup. My lookup's going to return back a regular old Java object. I don't want to work with that as a Java object. I want to work with that object as a remote calculator. So I perform a simple cast. The results of that cast go into the calculator variable there. Go ahead, perform my operation. Realize again that this application, standalone Java application, running outside of the application server. So this means when I call calculator.add, I am making a distributed programming call from the virtual machine that's running the application to the virtual machine that's hosting the EJB. When I make the call to the virtual machine that's hosting the EJB, I'm actually interacting with a proxy, and the proxy behind the scenes is interacting with the actual EJB object. The data that I pass into add is marshaled automatically across the wire for me. The result that's returned is marshaled and unmarshaled automatically for me. So it looks and feels like I'm doing a local Java call. I go ahead and print out the result and move on with life. So there's a very basic example of a JNDI lookup and a very basic example of accessing a remote session bean. Any questions on that? Okay, great. Let's move forward. Next example, which is probably more relevant to you, is a web application accessing an EJB. And the first example here in this web application is that I am using JNDI within a servlet to look up an EJB. We've already covered how to build our initial context. We've already discussed about the JNDI path. So all we really need to do is look at the code. Very basic example of a servlet. In this example, I go ahead and create my initial context. Again, I do my JNDI lookup based on the fully qualified class name. I cast the results again so that it is a valid remote calculator. And then you'll see down here in my do get where I'm actually performing my work, I use the calculator as if it's a local object. Okay, again, behind the scenes, it's making that remote call from the servlet to the EJB, potentially running in another virtual machine on another physical machine. There may be some new syntax to you here, depending on your level of experience with servlets. On line 19, there is an annotation now available to us starting in Java EE5 that allows us to create a servlet using an annotation instead of the web.xml file for the configuration. So everybody hopefully knows how to use JNDI. It's not the greatest thing. There are some issues like keeping track of bean names and paths and things like that, but it's pretty robust in that it's easy to use and you can work with it without too many issues. The challenge with JNDI, again, is that I, as an application developer, am asking the container, or I'm asking my operating environment, so to speak, for a resource. So I need to be fully aware of my own dependencies. In the kind of modern programming world, people are moving more towards the inversion of control or inversion of dependency mechanism, where my application environment is smart enough and intelligent enough to look at my application, infer based on the application what my dependencies are, and hand me those dependencies. So the industry has kind of settled, has generally settled on the term called dependency injection. There was a debate for a while on whether it should be called inversion of control, an inversion of control container, which is terminology that Spring uses, or a dependency injection container, which is a terminology that Sun and the JCP uses. Most people now have kind of settled on the dependency injection terminology. But the idea here, again, is that the container is going to do all the heavy lifting. The container is going to do all of the JNDI lookups. The container is going to do all the casting. The container is going to manage the pathing, all of that stuff to find the appropriate resource that I need and hand me that resource at runtime, not at compile time, so that I can interact with dependency. Dependency injection was introduced in Java EE5. Again, I said earlier on, it was matured in Java EE6. Dependency injection supports injection of 4 primary different things. I can inject an EJB. I can inject entity manager. I can inject a persistence context. And then I have the catch-all. I can inject a resource. A resource could be a data source. A resource could be a JDBC connection. Resource could be a JMS queue, so on and so forth. I can use, starting with EE5, I can use dependency injection not only in enterprise JavaBeans, but I can also use dependency injection within the web tier components, JSP servlets, JSF, things like that. There is another piece of functionality which is commonly referred to as an application client container. This was kind of made popular by Glassfish and a couple of other application servers. The idea here was that you could get a pared down representation of an application server and use that in a Java SE environment, primarily to help manage transactions, distributed security, and JNDI lookups. So if I have this application client container, which again is a Java SE application, it also supports dependency injection. To be honest, it's not the most common thing used in the industry today, but it does exist. And some of the examples that you'll see online, specifically Sun's examples in their tutorial, leverage this application client container. So to do dependency injection, all I need to do is annotate a variable with the appropriate dependency injection annotation. Again, remember, resource is the catch-all for a bunch of different types. Because we're dealing with dependency injection of EJBs, we might as well use the appropriate EJB annotation, which behind the scenes is just going to tell the container to, look up the EJB based on the type of the reference, which should be the interface type of the bean. Let's look at an example. Here is our servlet rewritten, this time to use dependency injection. And so you'll notice what we do here is we create a variable. The variable is of type remote calculator. That's the interface. We annotate that variable with @EJB. So at runtime, after that servlet is created, after the servlet's created, after the constructor is invoked, after the servlet init has been invoked, then the container is going to go ahead and try to inject the reference to the EJB. So because the EJB is specified with the default notation, again, there's no supporting parentheses, what's going to happen is that the container is going to use remote calculator as the type. It's going to convert that type into the fully qualified class name. So whatever that is, com.developintelligence.tutorials.ejb3.remote-calculator, and then it's going to use that fully qualified class name in string form to do its JNDI lookup. Assuming that works, I'm going to have a valid reference to the calculator. And then you'll see my code down below looks exactly the same. Questions on that?
Later on, are we going to take a look at how to specify an implementation if there's more than one implementation associated with an interface?
You cannot do that anymore.
You can't do that anymore?
Nope.
Okay.
Not if you're going to use dependency injection. You cannot do it.
Okay. And what's the difference between @EJB and @inject?
@inject is not a Java EE annotation.
Okay. And
so go ahead.
And so we could have used @resource there and specified a resource, or we could use @EJB since it really is an EJB.
Correct. Yep.
Okay.
Yep.
Cool,
Exactly.
thank you.
You're welcome. Other questions?
If you can use both, why do you have two? If you can use EJB and if you can use resource, why have EJB and resource? Why not just have one or the other?
I didn't get invited to that specification meeting discussion. How's that for an answer?
Good.
Simplistically, using the @EJB annotation, it just means that I don't have to specify as many attributes when I do my resource lookup. It's got some additional default JNDI lookup behavior.
Okay. For the remote interface, where is the information stored? Like where exactly the remote JVM is running, or how to connect to it, and if we just say remote, like, isn't there some more information for the lookup, remote JNDI lookup, or because they're two separate JVMs now? How is it, and they could be anywhere, so how is it finding the actual endpoint to connect to?
Say that again? Ask it again?
Remote call, you have
Yep.
the EJB running in a separate container and a separate JVM, and you're just running this Java app in a separate JVM with its own virtual machine, and we're just using the remote interface. So how does it know to connect to that, to any particular instance, or where it's running, or, I mean, we could be running in a separate machine, or...
So you're asking how the JNDI finds it in another JVM?
Yeah.
Right, so the JNDI properties on that secondary VM need to point to the JNDI tree on the primary application server. Is that what you're asking?
Yeah, so is that a URL?
Yep. Well, depending on the implementation, depending on the provider, right, it could look different. I don't know if that makes sense, but some application servers have different connect strings and require different parameters as part of the initialization of the initial context. Right, that example on page 79 in that PowerPoint, that's the minimal that you need, the provider and the URL.
So is this on the same web port, or is it running on some other port? Is it on port 80 or?
Generally, it's not on port 80. It's on some other port that defined by whatever application server I'm using.
Okay.
So in this specific example, would it be looking up the context, the component in JNDI through the fully qualified package name, because we didn't specify anything about the JNDI, any additional attributes in the annotation?
You're talking about the servlet example?
Mm-hmm.
This one right here?
Yeah.
Yeah, so it's going to look up that calculator based on the fully qualified class name of the interface.
And that's how it would essentially identify it in a separate JVM.
Correct. Correct. Yep. Did I answer your question?
Yeah.
Okay.
Well, everybody's smiling. I think we might have it. Got it.
Okay. Cool. And remind me, you guys are using JBoss, right, as your app server?
Uh-huh. Yeah.
Okay.
Yep.
So usually when you deploy, I haven't worked with JBoss in about a year, but usually when you deploy an EJB, JBoss spits out in its log, right, where it deployed the references in JNDI, or do you have to go and look at the actual JNDI tree? Does it in the console? Does it show you the path that it used?
I mean, we don't use EJB that often. I don't know.
Yeah, but even if you deploy a servlet, maybe it doesn't do it.
Yeah, I think more often than not, we actually use the JMX Console within JBoss to take a look at what's in the JNDI tree. So it might be in the logs, but I'm not certain.
Okay. Yeah, so if let's say you build one of these EJBs and you deploy it into JBoss and you open up the JMX console. You will actually find the EJB probably not deployed, but registered with JNDI 3 or 4 different times. So that, let me see if I can find that slide. Give me a second. Not that slide, hold on. There we go, slide 80. So when you look at the JMX console, you could potentially see the EJB register with JNDI 4 times, depending on how you've deployed the EJB. If the EJB is deployed just within an EJB jar, you're probably going to only see this qualified class name and the Java module bean. If it's deployed in an ear, then you might see the app. The app will be whatever your ear's file name is. Module name will be whatever your EJB jar name is, and then your bean name. So the point there is that when you go to play around with this, definitely keep the JMX console up, and you can see how JBoss is registering that EJB different ways. The default behavior from a dependency injection perspective is to find the resource that is closest to the servlet or closest to the EJB in terms of the context. So I'm going to look at if I've got an EJB, 2 EJBs deployed in the same EJB jar, it's going to look at the context of that EJB jar first, which would be the module. If it can't find it there, then it's going to look at the app. If it can't find it there, then it's going to go look at the global. If it can't find it there, then it's going to go look for the qualified class name. I don't know if that helps or if that just added more mud to the already murky water. Other questions before we look at the session facade idea?
Nope.
Okay, great. So session facade is just a general, it's a specific implementation of the general facade pattern. Facade pattern you may or may not be familiar with. The idea is that it's going to provide a unified interface to a set of subsystems or a unified interface to a set of interfaces defined by a subsystem. Usually facades are going to simplify interactions between the client, caller, and the subsystem. It's going to simplify interactions in terms of the exposed APIs, simplify interactions in terms of the data that I'm going to pass in, the data I'm going to receive back, and simplify interactions in terms of exceptions, maybe hiding low-level application exceptions, converting them in, or low-level Java exceptions and converting them into application exceptions. In the EJB world, this idea of a session facade is pretty common. Generally, if I were to look at an EJB application, I have many different enterprise Java beans. Each enterprise Java bean is responsible for some aspect of the workflow logic or some aspect of the broader business logic. And instead of forcing the client to keep track of all of those different enterprise Java beans, and instead of forcing the client to keep track of the appropriate order for the interactions across those enterprise Java beans, people generally roll up all of those EJBs or the interfaces to all those EJBs into some facade. And then from a client perspective, I, as a developer, of the client just call the facade, and I let the facade delegate the interactions and the order to the appropriate EJBs. So facade's pretty popular in the EJB world just because of the simplified interface aspects. If I were to look at the implementation of a facade, one strategy is to create a facade that has a remote client access that hides or abstracts, not abstracts, encapsulates, sorry, better term, local EJBs. So instead of me exposing remotely, some algorithm that I use for, reservation number, or some algorithm that I use for validation of a credit card or something like that, I make those beans and the business logic for those correlating steps hidden as locals, and then I wrap them in a remote bean. The client accesses the remote, never knows that the local beans exist. So that's a pretty common scenario. It's going to look something like this when I go to implement it. Remember, I'm going to need an interface for the facade. I'm going to need an implementation class for the facade. I'm going to need an interface for bean A, an implementation for bean A, an interface for bean B, and an implementation for bean B. And the 1 and 2 there really just represent that when I invoke some method on the facade's first going to go and invoke bean A, and then it's going to go and invoke bean B. So if I were to go to create a facade, I obviously need to create an EJB that accesses other enterprise Java beans. And I have, again, my two different options, right? One option is that I can have an EJB that uses JNDI to look up the supporting EJBs, or I can create an EJB that uses dependency injection to get a reference to the supporting EJBs. So here's an example of an EJB using dependency injection. In this particular case, again, I'm specifying the @EJB annotation. The type will be used to look up that EJB in JNDI. Reference is going to be placed into that variable after the constructor executes, so post-construction, it's initialized. And then obviously simple implementation of logic at that point. The only thing that's potentially different in this example from the servlet example is that I'm in an EJB, but everything else is going to work exactly the same. From a client perspective, from a client perspective, the example here with this client, you'll notice that we're using an attribute of the EJB annotation. In this particular example, instead of just saying, hey, give me the remote calculator, we're saying, give me the remote calculator that's called calculator. So the name calculator that we specify is used as the key in our lookup. And in order for that to work, I do have to change how I'm defining the stateful bean. I have to specify what the map name is. Okay? But after that, when I call calculator.multiply, remember behind the scenes remote calculator is going to call, flip back to this slide, remote calculator is going to call the singleton calculator bean, which actually performs the operation. Questions on that code example?
The original calculator was stateless, and when you implemented the facade, it became stateful, or is that the state of the facade? Is it something that we need to take into account, or?
Yeah, it does. I mean, it just depends how you want. It's really a design decision based on your application. That's nothing to do with the facade pattern per se. Is that what you're asking?
Yeah, I was just like, in again, because the facade is you're trying to cover so many other operations, is it generally that it's going to be stateful because of the way that you interact with it, or it's just based on the application? And I think
it's primarily going to be based on the application and what you're trying to do.
Okay.
Now, how do we know that we're programming to the interface and not the implementation right now? Because if I look at the code on the next page, I can't really tell whether I'm programming to the interface or the implementation.
Right here, remote calculator.
Mm-hmm.
Is the interface of that bean.
Gotcha.
Is that what you were asking, or did I miss something?
Nope, that's what I'm asking. And since there is only one implementation of the interface, then we know that we have that specific implementation.
Exactly. Yep. Yep. Yeah, in the EJB2 world, I could have one business interface that was implemented by multiple beans.
Mm-hmm.
In the EJB3 world, that functionality goes away.
Okay.
If that's where the question's coming from.
And the reason that functionality went away is it just went away in EJB3. It doesn't have anything to do with annotations versus JNDI. We couldn't have multiple implementations and look them up via JNDI. It's just not there anymore.
It went away because of dependency injection.
Okay. Makes sense.
Yep.
Because that's kind of one of the nice things about...
Go ahead.
I was just saying that's kind of one of the nice things about Spring is that you can control what you specify as your implementation and your interface.
Right. Right. And I think the motivation for Sun was to make EJB as stupid simple as possible to use, because there was so much pushback from the community previously on how hard it was to use.
Yeah, that was full circle to a nightmare.
Right, exactly. Yep. And to be honest, Spring has been doing dependency injection for a lot longer than EE5 has, or even EE6. So I would assume the dependency injection mechanism with EE will get more robust over time. But the way that I would look at it is that it's kind of in its infancy stage of a dependency injection container right now.
So with the DI functions, you can't externalize your configuration into some XML file. It will be through JNDI or annotations.
No, you can still externalize stuff through XML.
Oh, okay.
But you can't. But you're not going to externalize the actual, like in Spring, I can externalize the physical injection dependency in an XML file.
Mm-hmm.
And in EE, all that I'm really configuring in an XML file are the JNDI properties for my bean, so to speak.
Oh, so the attributes on the annotation, essentially.
Exactly.
Okay, gotcha.
Exactly. Yep. Other questions? Okay, I'm going to suggest that we take another short little break. I have 22 after. Let's say 35 after. That'll give me enough time to run to the restroom, and you guys maybe enough time to grab a soda, something like that.
Snicker bar.
So, or beer. What was that? Oh, so
that sounds better, yeah.
yeah.
Okay.
So 35 after, we'll start back up.
Thank you.
Deal, thanks.
Thank you. Please stand by.